just do exchange. Oh no, it's now it's mirrored. All right, would like to welcome the next speaker, Ariadne Conill, Wayback, a Wayland compatibility layer for X desktop environments. Welcome.
Hi. I'm Ariadne, and I'm a security engineer with an SRE background, so, you know, I'm probably a weird person to be talking to you all at XDC. However, I've been working on Alpine from 2009 to present. I've written a lot of utilities in Alpine towards that purpose. PackageConf, for example, which is our rewrite of package config. We did that for improved cross-compilation support and things that we needed for bootstrapping the distribution. The Alpine networking stack, also IF up down in G, which is also in Debian now. libu context, which is a muscle compatibility thing, gcompat, which is another muscle compatibility thing. Lately, I've been mostly dealing with the security team, 2021. Onward, my focus is on planning around long-term sustainability in our software distribution that we do, and that's what brings me here. You can follow me on Mastodon and Blue Sky, of course. So we're going to talk about Wayback, what it is, why we made it, how it works. There might be a demo. There were some technical difficulties earlier trying to get video working, but it seems to be working now. And of course, what we need from the greater free desktop X community to basically get this thing to what we would call a 1.0. So what is Wayback? Basically, to understand what Wayback is, it is something that is vaguely shaped like the standalone X server that we used to use back in the day. Nowadays, we usually use Wayland. The way that we do this is we have a stripped down Wayland compositor that basically the only job that it does is it outputs video from X Wayland and it forwards input to X Wayland. So all of the actual X stuff is handled by X Wayland, and then we have some supplemental tools to glue everything together. Why did we build this? I'm sure there's a lot of people here who work on distributions. I see a lot of Red Hat people around, for example. Alpine, of course, is a community-based distribution. There isn't a company behind it. As a result, we have a large cohort of stakeholders. For example, there's governments using Alpine, NGOs, large enterprises, small office, home office, hobbyists, and of course embedded, post-market OS being kind of the main embedded focus. The security team has to plan around all of these different use cases and find appropriate balances. For example, the direction things are going is obviously in a Wayland direction, but there are users out there who have built on top of X and telling them, you know, X is, you know, going out to pasture, you need to move over to Wayland isn't really an option that resonates with those people. So let's talk about X11's maintenance situation. The maintenance upstream is obviously shifting towards Wayland. And X Wayland is mostly seen as a backwards backwards compatibility layer for legacy X applications, of course. If you boot up KDE or GNOME or whatever, it starts X Wayland in the background, and then if you have an X application that you need to run, it runs X Wayland in rootless mode. That's cool, but there's a lot of people out there who still use like Window Maker or XFCE, although XFCE is starting to move toward Wayland as well. But more interestingly, with the Asahi project, we've noted that X Wayland applications actually perform better with a Wayland compositor and X Wayland over using legacy X with like the mode setting driver. And that's because the modern Wayland rendering pipeline is really designed around these modern GPUs. So because of that, we have X11 X11 is kind of this thorny thing in distributions because we know that's not the future, obviously, that's the past. But we still have users who, again, are married to it for whatever reason. They might have a Window Maker setup or a XFCE setup or Fluxbox or whatever, and they want that setup to keep working. So one approach that has been taken by the Wayland community is to build clones. For example, i3 got cloned into Sway. Generally speaking, for many use cases, that's fine. But for these users with highly specialized setups, they're worried about, regressions being forced upon them. So they also want things like tear-free rendering to work, which obviously doesn't work very well on X today. There are some patches, but it's not like in a release. So users also want direct rendering for gaming because sometimes if you have that double buffering caused by a compositor, that causes too much latency. Like for example, like in a first-person shooter type game where latency matters a lot because, if there's too much latency, then, that's the difference between getting out of the way of like enemy gunfire or whatever. But also, embedded users want improved GPU power management, and X, the model obviously being frame buffer oriented and all of that, doesn't really support that very well. For example, that's why SXMO has been, SXMO is a mobile desktop environment for phones, originally built around DWM. They are now looking at porting to Sway. I think you can install a build of XMO that uses Sway today, but it's not an entirely equivalent setup. There's trade-offs. So because of that, we want to keep X working, but we want to do that in a way that is not intrusive or with a lot of overhead for distributions to maintain, because distributions, we have lots and lots and lots and lots and lots of problems that we need to solve, and X is a big one right now, but if X wasn't a problem, then, we wouldn't want to go solve it. So when talking about the current situation with X, we're presented at the distro level with three basic options. The first one, of course, is the status quo, which, that's a low development cost to us. It's basically nothing, but the user experience will continue to degrade over time as attention has shifted away towards Wayland for a lot of good reasons. There's fork X and maintain it. We're going to talk about that. It'll be a little bit interesting, but naturally we've rejected that fork for reasons I'm going to go into. The third option, which is what Wayback is, we leverage Wayland to keep X11 desktops working. The initial cost, of course, with that is high because we have to do a bit of work to plumb everything together. But once it's done, it's done. You know, it moves along with Wayland as Wayland evolves, and we get all of the Wayland features, hopefully, for free. This has been done before. Somebody put together a proof of concept with shell scripts called X11, where basically married together Wayland to Weston running in a full screen mode. What we've done is basically a streamlined version of that. So let's talk about the X-fork. You know, when X Libre was first announced, distro people were like, yay, our X problem is solved, maybe, you know, because there's a fork, we don't have to worry about it anymore. Unfortunately, if you dig deeper into X Libre, it's a reactionary project. They deleted everything relating to Wayland, which means we still have to, that's actually worse for us because now we have two different X stacks that we would have to maintain. From what I could tell looking into it, there was no formal plan, no roadmap. Development is discussed in a effectively unmoderated Telegram group chat. They have no code of conduct. The content in that Telegram chat would be a code of conduct violation for me to share with you, so I'm not going to, but it's really vile stuff. They've also added a pointless X namespace thing, which they claim is security, but anybody who has an actual understanding of security fundamentals realizes that the X server is a single unified security domain, and if you just label different windows, that doesn't really get you anything. On top of that, the maintainer, the lead maintainer, I guess, I'm not entirely convinced that he knows what he's doing, because we've found, at least when we first looked at it, a number of change sets that I think have been reverted now in the free desktop tree that he got included that basically, how do I put this nicely? These are elementary C level or elementary C coding mistakes. Like, for example, he thought the XOR operator was a multiplication operator, for example. So instead of getting 655, anyway, whole thing. So what is X and why do we care? Because we have to understand from an architectural level what we're trying to do. This is a really simplified version of what a modern X server setup looks like. You have your X11 applications. They speak the X11 protocol to the X server. The X server has two major components, device-independent X and device-dependent X. The DDX, as it's called, is where our main concern is, because a lot of those drivers are just kind of sitting around. If somebody finds like a major CVE, there might be a fix that gets released, but maybe not. And on top of that, a lot of the DDX components, every time a new GCC comes out or a new C-Lang comes out, they fail to compile. So we have to go and fix them, and it's a whole thing. But basically, you have libinput as the primary DDX for input, and then the DDX uses XF86 mode setting, which then goes into the whole direct rendering infrastructure, KMS, so on, all the stuff that everybody here is working on. With Wayland, we still have X11 applications speaking X. They speak to Wayland. Wayland does away with the DDX. Instead, it talks to Wayland for all of the stuff that the DDX would do. As a result, the lib input goes directly into whatever Wayland compositor that you're using, Weston, Mutter, Kwin, whatever. And that compositor obviously talks directly to the GPU via the direct rendering infrastructure. And so what we've built with Wayback is essentially something around, just a small wrapper around Wayland. So we have the X11 applications talking to Wayland still, that hasn't changed. Wayland talks to a component called the Wayback compositor. That's the compositor I talked about earlier, which is stripped down. Like I said, the only job that it has is display video and take input and route it back to Wayland. We don't even export this compositor in a way that it can be publicly used. Instead, it's passed as a file descriptor to Wayland using SCM rights. And so most of the actual work is being done by WL Roots, which is the framework that a lot of Wayland compositors are built on. Sway, Sway's the big one. There's a whole bunch of other ones that use WL Roots. So to sum everything up, we have Wayback compositor. That's the stripped down compositor. We have Wayback session, which we're getting rid of. That was just kind of a temporary thing to allow us to, get started. And then we have this thing called Wayback, which is essentially a stub drop-in replacement for user bin X. And any tool that interfaces with user bin X, the intention is that Wayback is a drop-in for that. I can demonstrate that if it will cooperate, but other than that, where we are today, it is mostly working. People are using it as their daily X server instead of the standalone Xorg X server. But we need a few things to really get this over the finish line. X has two key extensions, X resize and rotate, commonly known as XR and R, and Zynorama. Essentially, we need Wayland to be aware of the display topology from the compositor, and we need X clients to be able to talk back to the compositor so that the compositor can do things like change the screen resolution, or the compositor can say you have 2 screens, 3 screens, etc. So essentially, that's what we need for multi-monitor to work. Another big one that we need is color space management. For example, there are different applications that have different color spaces. For example, there's sRGB, and then there's like YUV and all of that. We need some way for the compositor to be able to talk with Wayland and say, use this type of color space, because people use graphics packages to basically do graphics in these different color spaces, and if it's not correct, then when they go to print out the graphics later, they don't get the result that they're expecting, and so that's why that's important. And then the big other thing that we need is DPMS, and that is so that like X screensaver, for example, can turn on and off the screen after, some amount of idle time. I can demonstrate this now, but the main reason for me coming here is to start a conversation about how we can get these three main things plumbed so that once they're plumbed, we can call this pretty much done and, move on from there. The other big thing to be aware of is legacy hardware. For example, there are DDX drivers that support these 2D only chips out there, like I think ASpeed is still making a variation of like some old Matrox 2D only chip, and at the moment kernel mode setting doesn't support that, so we need some way also to support these older chips. I think there is a talk later today about finding a path to supporting these older chips, but that's like kind of the fourth concern, but that's a minor one by comparison to these three. So where can you get it? At the moment, it's an Alpine Linux Edge, which is our rolling release. That also means it's in post-market OS Edge. The installation instructions are the same. It's also in Fedora Rawhide, and Arch Linux has a package in the AUR. There's a couple of other ones, T2 SDE and a few other ones, but those are the big three. So with that, I can try to demonstrate it, but my computer is having some weird video issues with this infrastructure. It's kind of miraculous that it is working at all. But we have, we're on Libera chat, that's Bridge to Matrix. We have a website. I'm also here, and yeah, anyway, so if anybody has any sort of input, questions, etc., on how we could get this done, I'd love to hear them. Otherwise, I can try to fire it up in nested mode and show you all that it is in fact working.
No. We do have about 20 minutes, so you can go ahead and try, definitely, while we're preparing the questions.
Sounds good. All right, in that case, so if we use Wayback session, which you shouldn't actually use, but I'm going to use it here, we can fire this up, and as you can see, we have an X server. We use the old stipple background with X Wayland, mostly as a debugging tool to show us that the X server is actually alive. A nice thing is because we are building on WL roots, we get nested mode for free. So for example, if we do, and everything is working as you would expect. So for example, if we do glx info, we have actual hardware rendering. For some reason, the cursor is not showing up now. I'm gonna say that's probably some weird Qualcomm issue, or Freedrino issue, I should say. This is on a Snapdragon laptop. But if we run like glx gears, as you can see, GLX Gears is working as expected. But again, once the actual protocol is wired up on the Wayland side, it should just work.
Hi. Has anybody considered using this as a wrapper for individual programs? So like the processing IDE, for example, which is all old Java stuff that does not work on Wayland and doesn't seem to behave that well with Wayland satellite in my case.
That's basically what that's originally what the Wayback session command was intended to provide. In that case, it gives you the Wayback compositor and rootful X, and then that should enable like the processing IDE to work. We might actually wind up keeping Wayback session around just for that use case because it's only like 100-ish lines of code.
Cool. Thank you.
So this might be a kind of backwards question, but you said that the Wayland compositor part of Wayback isn't exposed to anything. So that would mean that inside of Wayback in the X session, you can't run a Wayland application, right?
Correct.
So, right. And a lot of things, justifiably so, are ripping out the X11 backend from themselves and just, we have Wayland, if you don't run Wayland, that's your problem. Could it be made in such a way where you're actually able to run Wayland in the X server?
Yeah, there is a project ongoing. Actually, there's a couple different projects ongoing that provide a rootless Wayland compositor that can be used with X. So if you can imagine basically like a whole bunch of different adapters plugged into each other, yeah, you can get Wayland applications running on X without the need for a rootful compositor. And then they work basically as you would expect. Your X window manager manages them and all of that, but that's out of scope for Wayback. In the case of Wayback, we're just providing the quote-unquote X server part.
Hi, thanks a lot for that project and your talk. If you could surely go back to the slide with the open, the to-be-solved issues. I wanted to quickly ask regarding the X and R. I mean, we have, I suppose you're aware of this existing like emulation of like mode setting. I just wanted to ask if you could quickly elaborate if that's actually, like, do I understand correctly that this is not enough, like emulation wouldn't be enough of mode setting, but you need like actual mode setting from the compositor?
We've done some experimentation with using what they call the Wayland viewporter extension to emulate it, but the problem that you get with that is that the graphics output is scaled, and so when you scale something up or down, you lose visual fidelity over just having the raw mode setting. So that's why having the mode setting is important, because if we tried that, and then people did, experimented with the mode setting, and then it resized the virtual, viewport, but then they were like, well, I changed it to, such and such resolution, but my fonts are fuzzy now versus without. So that's why we need the actual mode setting. But I think for a lot of things like games, for example, it might be a good enough answer, because when you're playing like a game, visual, like that level of visual fidelity isn't necessarily the most important part, because you're wanting to play the game, you're not wanting to admire it for its visual fidelity. But like, for example, like a desktop publishing application or whatever, you need that crisp text in order to,
Okay, so but there's no other like technical reasons apart from the quality, which could potentially be improved even in the viewport implementation or something.
Yeah. I mean, there are certainly different scaling algorithms that have different trade-offs. Like, for example, in the manga kind of like fandom, there's an algorithm called Waifu 2x or something that uses the GPU to scale in a way that, keeps the edges clear. But the problem there is, as far as I know, that algorithm is pretty computationally expensive on GPUs. So if you're trying to like do that on a laptop, for example, that might drain battery life significantly over just direct mode setting.
Yeah, I would like to just shortly bring up there that there's even in display engines, I think there's some stuff that could potentially be used there. But just as a note, a further question regarding color space management. If I understand correctly, like with the new protocols for colors, like the color representation Wayland protocol, what is that missing? Or couldn't we just use that in Wayland to give you roughly what you need there?
Yeah, I mean, in a lot of cases, protocols already exist to solve this. It's just a matter of sitting down with the people who maintain Wayland, which my hope is that they are here so that we can sit down and figure out how we're going to get this stuff hooked up and get it out to users, so that, say, by next XDC, I can come back and say, we have, gotten rid of legacy X in Alpine, for example. But it's just a matter of sitting down and figuring out how we're going to actually do it. So that's why I'm here.
Hi, the performance issues on Asahi Linux might be actually a bug in the Mesa driver I fixed in June. So it could be potentially just an issue of showing the slowly deprecation of X support and not actually a fundamental issue.
I mean, that's a good observation. In my case, I don't personally use an Asahi device as my daily driver, but talking to like Lena, for example, what she indicated is that using a Wayland compositor over XF86 mode setting delivers better performance in terms of like FPS and all of that. So.
Yes, it is certainly a much better fit for the architecture.
Yeah.
Hi, I speak to quite a lot of users who are still wedded to X, and one of the more common reasons I hear is to do with latency, especially around, things like tearing and mouse cursor movements, where some users just really want that kind of low latency tearing, and because Wayland has this thing about being frame perfect, is that just always going to be incompatible, or is that something you think you can kind of, a need you can solve?
Yeah. Different proposals that at least I'm tracking to add a direct rendering protocol to Wayland, where you can tell the compositor, I want direct rendering, I don't want to go through a composition step. So from like a Wayback perspective, that would be like an on-off switch that the user could request direct rendering mode or buffered rendering mode. In general, I think in a lot of cases, even on X, you're not really getting direct rendering anymore because most X setups have a composition manager running in the background, and if you're running like KWin or GNOME or whatever, all of those have a composition manager, and so by the nature of having a composition manager, it's honestly, in my opinion, I think a lot of what those people talk about with that advantage, I think it's a placebo effect, to be honest with you.
I mean, to be fair to them, at least in our case, we've done measurements where with OpenBox on X versus LabWC, WR Roots, Wayland, there is a sort of a noticeable latency difference in kind of mouse movements and when you click on something. So there is something there.
Oh yeah, absolutely. But like, I'm talking about like, I see that complaint from people who are running like KDE or
Yeah, it's definitely overblown.
GNOME, and in that case, they're running on X with Composition Manager anyway. So in that case, I do think it's a placebo, unless they are somehow going and turning off the Composition Manager somehow. But I don't think that's, at least, I'm not sure how you would do that, like on KDE or GNOME. I'm pretty sure they don't expose a setting to turn off the Composition Manager. On XFCE, it is possible. But obviously, if there's no Composition Manager running, then there is a latency advantage, and that's what the direct rendering protocols that are being proposed are intended to solve. I think the primary use case there is really gaming, like I said earlier, because, you know, if you have like a 1 or 2 frame difference, especially like in a game like Counter-Strike, I mean, that's the difference between, you know, being, you know, having to respawn versus not having to respawn, right? So, I don't know, but yes, with OpenBox, because there's no composition manager running, then yeah, obviously you get immediate feedback, but...
I think some people are also just very funny about their mouse latency.
Well, yes. I mean, there's certainly a lot of people out there who are picky about mouse latency. I mean, for example, but even on Wayland, it's not too bad. Like, I recently got an OLED display for my primary workstation, and on Wayback, the latency is not really perceptible even with the composition step, but maybe it's different on different hardware. I mean, my main machine's a AMD Radeon setup, but
Yeah, I think we're only talking like sort of a frame or half a frame kind of latency.
Yeah.
It's not a massive thing.
right. But the direct rendering protocol should solve that.
Yeah, I'll look into it.
Have you thought about direct mode, like basically shoving parts of the mode setting drivers into Wayland and then doing a DRM lease? So I think that's probably the road you're heading down, and will be faster and probably, you know, less code than the new direct rendering thingy. To completely bypass the compositor, because like I don't think those people with the mouse problem will be happy otherwise. Like,
I agree with you that sounds like a better path. The question is, how do we get there from where we are now? And, you know, that's why I'm here. You have to understand, I don't come from a graphics background, so you tell me about DRM leases, it's news to me. So if that is a path forward, I would love to talk about it, because, you know, if we can solve that would be great. The question is that something where if we go and bring a merge request into Wayland that implements this, will it actually get merged, or will we be wasting our time on it, basically, is the question that we need to get an answer to before we spend a large amount of time bringing all of that infrastructure into Wayland. Because at least my senses tell me that could be a little bit spicy, because you're taking a whole bunch of stuff that used to be in the DDX layer directly into Wayland, and that seems kind of contrary to the vision of Wayland, which seems to mostly be intended to be an adapter more than something directly driving things. But if there is a path there, obviously we would want to pursue it.
Just want to say that in KDE, as far as I know, which was like a year ago, maybe 2, you can disable compositing just globally, just off. And it also disables it automatically if it detects a full screen